Okay, so now I'm going over question 6. So the first concept I will go over in question 6 is a free body diagram. Free body diagram and how to do one. So basically a free body diagram, it's used to show the forces that is acting on an object. So now I'm going to give an example of it. So this is a block, and a force is being applied to it, so I write the force like that, and then it will have the weight is mg going down, and then we also write the normal force perpendicular to the surface it's sitting on. Okay, so that's just a basic overview of a free body diagram. Now I will go over breaking up an object into components. Okay, so I'm just going to give an example. So let's say there's a block sitting on an incline and it has a weight mg going down. So what's making this block accelerate down is not this weight, but this weight right here. And so I'm going to break this up into components. I have mg going down, and then that means this will be mg sine theta, and this will be mg cosine theta. So what's actually making the block accelerate down the incline is mg sine theta. And so that's important for this question. Okay, so now I'm going to read question 6. A block of mass m1 is connected by a string to a sphere of mass m2. The block is on a frictionless plane inclined at an angle of 30 degrees, as shown in the figure above. The string passes over a pulley of negligible mass and friction, and the sphere hangs freely. Which of the following is always true if the block is accelerating down the incline? Okay, so first I'm just going to draw the picture so we can do the work. Okay, so this is M1, and it is connected by tension to M2, and M1, and then this is 30 degrees up here. Okay, so it's asking for what needs to be true if M1 is accelerating down. So if M1 is accelerating down the incline, it means that this force that's making it accelerate has to be greater than M2. So first I'm just going to write all my forces that's acting. So here, M2, I have a weight of mg going down, or m2g going down. M1, I have a weight of m1g going down. Sorry, like that. So what I can do, I have 30 degrees here, so I can write it here, 30 degrees, and then I can write this is mg cosine 30, and this is mg sine 30. So now after breaking up into components, the one that's making M1 accelerate down is M1g sine 30 degrees. So what that means is that M1g sine 30 has to be greater than the tension than M2g. So that means M1g sine 30 is greater than 2g. So in order for it to accelerate down, it needs to be greater than this weight pulling it down. So then I can cross out the g's because on both sides, and then I get that M1 sine 30 degrees needs to be greater than M2. And so that means that the correct answer to this problem is E, using this. And so basically what it's saying is that this weight going down, M1g sine 30 degrees needs to be greater than m2g, because in order for it to accelerate down, it needs to overcome the m2g. So in conclusion, this question showed important concepts of how to do a free body diagram, how to break the forces up in a problem in order to solve and see what forces are acting on the object.